Hello dear children, in the previous classes we solved the numericals based on current electricity. In fact, we have been solving the numericals based on current electricity from past 3 to 4 classes. Dear children, as we all know very well that current electricity has three units and 3 exercise numericals which we have. So far we have completed numericals based on unit A, unit B. In fact, numericals related to unit C also up to 11 numericals we have completed. So today we are going to complete what we can say unit C, so that all numericals we are going to finish. So the related and what we can say links, whatever we discuss, the numericals which we discussed in the previous classes, the links will be given in the description. Just go through those numericals so as to have a good practice. Okay children, fine. So in today's class, let us continue the numericals from 12, because in the previous class numericals based on unit C we could cover up to 11 numericals. So in today's class we will be covering from 12 numericals to 20 or 21, whatever it may be. Okay, fine. So children, here look at here, numerical 12 children. So as per the numerical is 2 bulbs and their power ratings are given. Now they are asking us to find the ratio of their resistances. Children, if you can notice here, one common thing is there. Here power is a constant. So first let us think how power, resistance and voltage are related. So we know that power is equal to V square by R. So anyhow, as P is a constant, in 60 watt, P is a constant. So as P is constant children, we know that is R is proportional to the V square. So now let us make a formula here. R1 by R2 is equal to V1 square by V2 square. Here voltage is how much? V1 220. So this will be 220 into 220 by 110. Oh, it is 110. Sorry, it is 110. Otherwise everything will be same, right? Okay, now 110 into 110. So 110 once, 110 twice, 110 once, 110 twice. 2 2s are 4. So it is R1 by R2 is equal to 4 by 1. That is R1 is to R2 is equal to 4 is to 1. That's it. So simple. Don't make it complicated. Okay, fine. Now come to the 13th numerical. The power rating of a bulb is given. So then they are asking us to find the energy consumed in a 1 hour. So children, we know that electrical energy formula is what? Electrical energy is equal to power into time. Power into time. So if you can see here, power is given in 250 watts it is given, and time is given in 1 hour. So do one thing, let us convert this 1 hour into 3600 seconds. 3600 seconds. Then we are going to get an answer in terms of joules. So that is 250 into 3600. So this will be how much children? This is going to be 9, 1, 2, 3, 4, 5. That is what? 9 into 10 to the power of 5 joules. 9 into 10 to the power of 5 joules is the answer. Now children, second part of the numerical, they are asking how much time does it take in order to consume 1 kilowatt hour energy. So try to understand how much time does this bulb take in order to consume 1 kilowatt hour energy. So we know that here electrical energy is equal to power into time. So electrical energy is 1 kilowatt hour. 1 kilowatt hour. Power is given how much? 250 watt. But here kilowatt is there, right? So this 250 has to be converted to kilowatt. 250 watt. How to convert to kilowatt? By 1000. So 250 by 1000 into time. Try to understand. So time must be in hours. Try to understand. So time must be in hours. Is it clear? Fine. So now what will happen here? 1 is equal to 1 by 4 into time. So time is equal to 4 hours. That's it. So no need to convert into with the kilowatt hour only. Just express 1. Energy is given 1 unit. Okay, fine. Now come to the 14th numerical. Here it is water heaters. Is it like that? Okay, let us think. Okay, old one. Okay, so it's a water heater. Power rating of water heater is given 250 watt, 100 volt. Now they are asking us to, if such kind of water heaters 3 are used, then how much amount of current is consumed? Children, our plan is that first we will calculate a current consumed by one electric heater, then multiply with 3, because 3 are having same power rating. Is it clear? Fine, children. So here the first one. So we know that P is equal to VI. So I is equal to P by V. So power is given 250 by 100. So this is 2.5 ampere. 2.5. Each electric heater 2.5. For 3 means total current. I total. 3 resistors, 3 what we can say heaters are there. 3 into 2.5. So this will be 7.5 ampere. That's it, simple. Multiply with the 3. Now what is the resistance of each heater? Resistance of each heater. So we know that P is equal to V square by R, children. From this, R is equal to V square by P. V is how much? 100. So that is 100 into 100 by 250. 250. So 0, 0 cancel. 25 ones, 25 fours. 4 into 10 is how much? 40 ohm. Children, resistance of each heater is how much? Children, it's a 40 ohm is given. 40 ohm is given. Now, if such a heaters are used, each heater is used for 5 hours, what is the total energy consumed? What is the total energy consumed? Again, same idea. First, we will calculate the energy consumed for one water heater, multiply with 3, then you will get the total energy consumed. Look at here. So, third one is electrical energy consumed. Electrical energy consumed. So, power into time. Power into time. So, we are going to get energy in terms of watt hour. That is, so if you want, you can convert into kilowatt hour also. Children, power is 250. In terms of kilowatt means 0.25 kilowatt. 0.25 kilowatt. So, here power into 0.25 into 5. This is going to be how much, children? 5 5 is a 25. 5 2 is a 12. So, this is 1.25 kilowatt hour. Children, this is energy consumed for 1 watt, 1 heater. 3 means yes. So, here total electrical energy is equal to 3 times of 1.25. This will be 3 5 is a 15, 3 2 is a 6, 7, 3 1 is a 3. 3.75 kilowatt hour. Okay, na? Copy it. Let me check. Are you able to see the board? Almost it is. Just a second. Yeah, it is done. Yeah, it's fine. Just copy it more. This is 60 seconds. Children, come to 15th numerical. So, as per the numerical, it is given that a bulb is connected to a battery of 4 volt, but it has some internal resistance 2.5 ohm, through which 0.5 in the circuit 0.5 amperes current is flowing. So, first one they are asking to find the electrical energy consumed in a 10 minutes. Okay, so children, look at electrical energy consumed. Electrical energy formula what? V I T. So here V is given how much? 4. Current is 0.5. Time is 10 minutes. That is 600 seconds. So if you can calculate this, this will be 1200 joules. Clear? Fine. So second part of the numerical, they are asking us to calculate the resistance of the bulb. So directly some students will use V is equal to IR formula. V is equal to IR. So they know, they think that V value is given 4 volt, I is 0.5, then they'll think to calculate, but it is wrong. Why? Here internal resistance also involved. So you have to use I into small r plus capital R. Now let us substitute. 4 is equal to, children, 0.5 can write as 1 by 2. See, I is equal to 0.5. I am writing as half. It can be. So small r is given 2.5 plus R. So get this to this side. 4 to the 8. 8 is equal to 2.5 plus R. So R is equal to 8 minus 2.5. This will be 5.5 ohms. 5.5 ohms. Clear? Fine. Third part, they are asking us to calculate the energy dissipated. Children, whenever current passes through a resistor, in which form energy gets dissipated? In the form of heat. In the form of heat. So, energy dissipation in the bulb here. So, it is the energy dissipated. Energy dissipated, which is given I square RT in the form of heat only, right? H is equal to I square RT. I value is 0.5, that is 0.5 square. So 0.5 into 0.5, R value is 5.5, okay. Time is 600. So this, if you can simplify, you will get 825 joules. This is how we can calculate. Clear? Fine. Come to 16th numerical. As per the numerical, two resistors are connected in parallel. Then they are connected to the battery of 6 volt. Then they are asking us to calculate the power. Children, if you want to calculate the power in the circuit, actually, here two resistors are connected in a parallel, right? First, let us calculate the resultant resistance. So for the first one, first we need to calculate resultant resistance. Rp is equal to, we have formula R1 into R2 by R1 plus R2. So this is 6 into 4 by 6 plus 4. This you will get 2.4 ohm. Now let us calculate the power. So power is equal to, we know, power is equal to V square by R. So V square is how much more? 6 into 6 by 2.4. 6 1 ja 6, 0.4. So this will be 60 by 4. So this is going to be a P is equal to 15 watt. This is the power. Now they are asking us to calculate the power dissipated at A and B. So I think I can erase. Can I erase this part, children? 3, 2, 1. Okay, I need space. Fine. Now they are asking power dissipation at A resistor, at a B resistor. Okay. So we know that P is equal to V square by R. So power dissipated at A, right? So here V is 6 only. 6 into 6. A is how much? 4. So this will be 36 by 4. So this will be 9 watt power dissipated. Clear? Fine. Now across B, children, that is V square by R. So this is RA, it is RB. Same thing, 6 into 6. What is the resistance of the second one? 6. 6 cancel. So this will be 6 watt. That's it. Simple. As simple as that. Don't make it complicated. Come to the 17th one. Here two resistors are connected in a series and they are connected to the battery of voltage 15 volt and internal resistance 2 ohm. Then first they are asking us to calculate. Actually they are asking us to calculate what, ma? Energy. What is the energy dissipated across 6 ohm resistor in a 1 minute of time. So if you want to calculate that, first children, first you should calculate the total current which is passing through the circuit. For that, children, we know that actually V is equal to IR. But here R means what, children? R plus R. Look at here, because internal resistance also, don't forget. But two resistors are connected in series, right? 4 plus 6 is how much? 10. So this is going to be, V is given 15. 15 is equal to I 10 plus 2. So here I is equal to 15 by 12. This will be how much? 1.25 ampere current. So this much amount of current is flowing through the circuit. Okay, that's fine. Now we need to calculate the voltage, right? Potential difference across this. Okay. So how to calculate? Yes, we know that V is equal to IR. How much amount of current is flowing? Children, as these two are in series, the total whatever the current which is flowing through the circuit, the same amount has to flow. The 1.25. So 1.25 into 6. So this is going to be how much more? 7.5 volt. Okay. Now what we have to calculate? They are asking us to calculate the energy dissipation. Energy dissipation. Energy dissipation. Wait, this is over. Energy dissipation. Children, we across 6 ohm. We know that energy dissipation actually power into time. But power is what? V square by R. So it is V square by R into T. So V value is how much? 15, right? 15 into 15. R value is how much? R 6. Okay. Into time is how much? 1 minute. That is 60 seconds. If you can calculate, you will get 562.5 joules. So this is a amount of energy which is dissipated across the 6 ohm resistor. Clear, children? Copy it. $4.2 per unit. Then we need to calculate the total cost. Fine. So comes to the children, numerical 18. It is given that electric kettle, just think that it is a normal kettle, electric kettle. So children, when this electric kettle, when it is connected to the 220 volt power supply, in a 5 minutes, what are the water which is taken inside? It is reaching its boiling point. Now they are asking us that, what if it is connected to, if its voltage is falls to 200 volt, then how much time does it take to reach the same boiling point, that is 100 degrees Celsius only. Children, this is purely based on this formula here. So we know that heat, that is the energy, is equal to power into time. Power is nothing but what? V square by R into time. So this we need to apply for two cases. So for this case 1, first let us apply, children, here. So here H1 is equal to 220 into 220 by R, because in both cases same kettle resistance will be same. Now into time is equal to how much? 5 minutes. So 5 into 60. Okay, na? So 5 into 60, this is 300 seconds. It's a 300. That is H1. Now H2, I mean for a second case we are talking. So it is, what is the supply here? 200, not 2, yeah, it's correct, all right. 200 into 200 by resistance R into time. This has to be calculated. In both cases, children, the energy remains constant. Okay, now then these both must be equated. Look at here. So 200 into 200 by R into T, which is equal to 220 into 220 by R into 300. Let us calculate this. R will get cancelled. 2 zeros will get cancelled. These 2 zeros cancel. 2 ones are 2 11s are 2 ones are 2 11s. So this will be 121 into 3. So this will be 363 seconds. This 363 seconds, if you can convert into minutes, by 60 if you do, 6.05 minutes. Why we are converting into minutes? Because it is given in minutes only. So when this the voltage falls to 200 volt, then the time taken will be 6.05 minutes. Clear? Fine. And come to the 19th one. So children, can I erase this? Just copy this 3, 2, 1, because we are in the space. Okay, na? Okay, or else let us use, then we will come back. So here a toaster, where it is connected to the power supply of 220 volt, 8 amperes current is drawn in a 2 hours. Okay, it's what 8 amperes current is drawn. Then they are asking us to calculate the the cost of electrical energy consumed if it is operated for 2 hours. So first let us calculate the electrical energy used. So children, here electrical energy, that is energy is equal to VIT. So V is given 220. I is how much? 8. T is 2 hours. Oh, so 2 into 1 hour, 3600 seconds. So if you can multiply this, how much you'll get? Okay, let it be in hours, right? Because watt hours. Why need to calculate? So watt hours only. So we'll get 3520 watt hour, which is equal to 3.2520 kilowatt hour. Children, at any cost we have to convert it to kilowatt hour, because this kilowatt hour only we can call it as a 1 unit. Now they said that per unit 4.5 rupees. Then for this 3.52 units we consumed. So here cost is equal to 3.52 into 4.5. So this is going to be 15.84 rupees. 15.84 rupees. Clear? Fine. Now Come to the 28th numerical. Here an electric iron of power rating 220 volt, 2 kilowatt. So daily it is used 3 hours. Then what is the cost of electrical energy consumed in 1 week, they are asking. So first let us calculate what we have to calculate. We have to calculate the electrical energy. So electrical energy is equal to, we know it's power into time. So power is in kilowatt, okay, 2 kilowatt into 3 hours, 6. This is a 3, right? 3. So 6 kilowatt hour. But this is daily. They asked 1 week, right? So means what? 6 into 7, 1 week, 7 days we can take. So this is 42 kilowatt hour, which means what? In 1 week, 42 units are consumed. 42 units are consumed. Then cost is equal to, so number of units into cost per unit is how much? 4.25. So this how much it will be? It will be approximately 178.5 rupees. If it is used for a one, try to understand why I have multiplied with 7 more. This is electrical energy consumed in 1 day. Try to understand. But they are asking for a 1 week. So daily 3 hours means daily this much amount of energy is consumed. But 1 week means into 7 we have to do it. Done. Just copy it. We'll go to last numerical. Can I erase this? Are you able to see? I think today my marker is writing very light. Please can adjust. Okay, na? 3, 2, 1, go. Yeah. And here last question is related to the geyser. So geyser of power rating is given, children. Geyser of power rating is given. So first they are asking the current. So here power is given 1500 watt, okay, and V is given 250 volt. Children, we know that power is equal to VI. From this, I is equal to P by V. So that is 1500 by 250. So if you can, what we can simplify? 0, 0, 5, 5 is a 5, 30 is a, that is a 6 ampere is a current. Clear? Fine. Now they are asking us to calculate electrical energy. Children, this power, in order to calculate electrical energy, we need to convert it to kilowatt. That is 1.5 kilowatt. Okay. So 50 hours they asked. So here electrical energy is equal to power 1.5 into time 50 hours. So this is going to be 5 5 is a 25. Okay, it is a 75 kilowatt hour. Means what? 75 units are consumed. So this much energy. Now they are asking the cost. If cost per unit is 4.2 rupees. So children, now it is cost is equal to number of units consumed, that is 75, into cost per unit 4.2 rupees. This is going to be rupees 315. So this is how we need to calculate. So children, with this we successfully completed all numericals based on current electricity, unit A, unit B, unit C. Am I clear? So if somewhere any simplification went wrong, just try to just check once again. So whatever is right, yes, just you take that correct value only. But again children, once again I'm telling you, so you need to have practice. Here I'm having a practice, but how about you? So you are the one going to write exam, right? So what is my suggestion is that whenever you are a numerical is solved, so first pause the video, just try to do yourself. If you are not getting anyhow, here I am doing right. So you can cross check with the solution. Clear children? Fine. So children, with this all concepts of current electricity, even one short video and all numericals we upload in our channel. So all links I will give in a description. So whoever is just missed to watch the previous sessions and all these things, you just click the links which are given, so that what will happen, you will have a complete what we can say revision or a complete knowledge about the current electricity. And one more thing children, comes to the what we can say electromagnetism. Long back, if I am not wrong, I think almost 1 year, unit A and unit B of electromagnetism concepts were uploaded, but unit C, due to the technical issues, though it was uploaded, it got deleted. So many students are sending a mails to our channel So to upload, to re-upload, yes, definitely after a couple of days, definitely we'll try to just make a video on a unit C of electromagnetism, definitely children. And after that, what will be left, whatever is left, children, again we are promising you that each and every topic, including numericals, definitely in the next maximum will take 1 more month, everything will be uploaded. So that what will happen, so whoever is following our channel and whoever is depending on our channel definitely will get benefited. But my humble request is that please read the textbook, try to have your own notes, and if you have any doubts, just children come back to channel and just try to text your doubt. Definitely we'll try to just approach, we'll try to clarify that doubt, children. Okay children, thank you so much, all the very best.